session lah, so you need to attend that one. Okay, and then with regards to lecture, we have 1 hour and 2 hours lecture kan, 1 plus 2. Okay, for 1 hour lecture, it can be either online ataupun face to face. So as for my part, for next week kita akan buat online untuk 1 hour tu. Tapi untuk the following tu, it depends on the lecturer. Yang tu nanti kau kena tanyalah respective lecturer sama ada dia nak online ke face to face ke. Right? Okay, and then on to 2 hours lecture, kita akan buat macam biasalah face to face physically dekat DK9 ni. Right. Okay, ini kita punya textbook. Okay, inside the e-learning tu saya dah bagi e-book for this book which is on the power electronics. Author dia adalah Daniel Berhad. Ini the most easy textbook that you can understand untuk for power electronics. Yang lagi advance, yang lagi dia punya term dia memang susah sikit nak faham tu, nanti saya tak tunjuk lah. So yang paling senang lah Okay, nanti you boleh download lah dia punya e-book dia kat dalam e-learning.
Dia 7-12.
Tapi kalau awak ada nak sama dengan physical books pun boleh juga
Dia sedih.
Right, okay, all material kita upload kat dalam e-learning. Kita tak guna Google Classroom, kita guna e-learning Okay. Alright, so ini kita punya, semua dah boleh access ke e-learning? Alright. Okay, so hopefully ini harapan saya you boleh you can enjoy learning power electronics and you can be able to score.
Medium saya nak tanya.
Tak boleh.
Untuk kelas hari Senin
sentap.
kita kan medium. Kan tak? Kelas hari Senin kan kita pagi kan. 8 sampai 9 kan online kan. Medium macam kena habiskan awal je sebab dia ada kelas face to face 9-10. Bukan 9-12. Selepas tu 9-10, 10-12. Berdiri lah. Berdiri. So nanti tak fokus lah kalau kelas tu.
Recording lah, mereka kena upload recording.
Recording apa?
Mereka kena upload recording.
Recording.
Nak tengok golong final.
Yes. You got me. You know tak siapa? Kenapa dah ada tulis?
Oh, saya.
Oh, you study dah?
Ada video lah.
Oh, ya kau? Aku yang nak tengok.
Any lagi? Any more? Any question?
Okay, I don't need to tulis anymore.
Apa nak tanya berkenaan dengan power E? Ada? You. Ada?
Mana soalan?
Ada?
You ambil that
Okay. Alright, so we go for the introduction for this
Rabu esok kita
subject. Okay, so for this slide, we are going to look into the few section, which is what is power electronics, application, and also the computer classification on the multi-stage conversion and semiconductor switches. Okay, yang ni sekejap je. I think maybe around 15 minutes kita dah habis. 15 Okay. So untuk week 1 dengan week 2 ni mungkin lecture macam leisure lah. Lepas tu masak lah. Okay. Right, so we go for power. What is power electronics? Okay, the thesis, the definition of power electronics. So basically, power electronics is an electrical power processing that consists of few discipline atau few section where it consists of circuit theory, system and control, signal processing, electronics, electromagnetic power system, electrical machine, simulation and computer, and solid state physics. Okay, solid state physics basically on with regards to the switches Okay, circuit theory basically awak kena tahu dia punya KCL and KVL. I think you belajar waktu first year kan? How the current flow. Sebabnya kita akan ada circuit, so you need to analyze the circuit, produce the equivalent circuit. So in order to produce the equivalent circuit, awak kena tahu lah basic on KVL and KCL. Okay. Okay, and then on the circuit and control theory ni, basically kita akan tengok bila kita ada converter, kita connect with the loads, and then how to control dia punya output dia. Okay, so how to control output dia, kita akan adalah dia punya techniques and control that we need to use. Okay, signal processing, basically kita akan analyze the waveform. Sama ada dia punya waveform tu, is it following the theoretical equation or not? Okay, on the electronics, kita switches lah Okay, and then on the electromagnetics, basically with regards to the waveform. Okay, power system, bila kita ada the commutator being connected, few of commutator being connected inside the power system. Okay, electrical machine, you punya converter also can be connected to electrical machine, which is can be connected to DC motor or AC motor or EV, pun kita akan guna. And then on the simulation and computing, of course the analysis with regards to basically for electronic ni akan banyak simulation yang banyak waveform yang you need to understand. Kalau katalah macam ada perubahan kat waveform tu, sepatutnya awak boleh tahulah okay dia berubah sebab apa. Itulah power electronics tu, dia you tengok waveform you boleh tahu dah dia punya apa, dia punya problems dia, apa yang salah dia kat mana. Okay, so power electronic circuits convert from an electrical power from one form to another form using electronics devices. So basically kita ada, let's say we have DC power, we want to convert to AC power, we are going to use power electronic circuit as the intermediate stage, okay, to do the conversion. Right, so this conversion can be done using this what we call system, where it comprises of switches, passive energy storage, iaitu kita ada capacitor and inductor, and also you punya load lah nanti, and also control system. Okay, control system yang kita akan baca, kita tak buat closed loop tahu kan, closed loop and open loop. Okay, maksudnya tak ada feedback lah. Basically kita akan buat open loop punya system where we still need to control dia punya output, tapi kita akan buat in open loop, so there will be no feedback. Okay, so in order for you to control the output, kita akan guna few techniques. You can use either kita panggil square wave techniques, you can use PWM techniques. Kalau untuk rectifier, kita akan guna firing angle punya control. Kita akan tengoklah balik, you akan belajar on that. And also kalau untuk inverter, dia banyak lagi, dia ada few techniques lah, dia banyak sikit techniques compared to rectifier and DC to DC. Nanti kita akan tengoklah kemudian Right, so basically ini dia punya flow, the general flow Okay, it come from kita punya electrical source. It can come from kita punya non-renewable energy source ataupun renewable energy source. Okay, and then from this, let's say from our grid, our main grid. Okay, so main grid kita, let's say kita supply AC. So from this is so AC, we are going to, let's say kita punya motor yang kita nak guna adalah DC motor. So in order for you to convert from AC to DC, kita akan guna komputer kat sini lah, which is you are going to use AC to DC converter, which is a rectifier. Okay, in order for you to do this conversion, so kita memerlukan controller dekat sini to control that. Okay, input pada kita punya controller ini adalah kita punya reference, sama ada AC signal ataupun DC signal depending on the load. Kalau you punya load require DC signal, kita akan bagi reference pun DC. If your load require AC signal, your punya reference akan jadi AC signal. Okay, simple macam tu saja. Right. Okay, sensor kat sini adalah untuk measurement bila kita ada feedback lah basically. So
based on load.
Ini voltage ke current measurement? Current sensor. Tahu tak? This one is it current sensor or voltage sensor?
Voltage.
Current.
Voltage.
Kenapa voltage?
Sebab
Check dulu.
Voltage ke current? Voltage.
Current.
Tahu ke tak tahu?
tak.
Tahu kan?
Voltage.
Tak pernah nampak ke?
Tak.
Tak boleh tengok macam tu lah.
Okay, this one is current sensor. Sebab apa current, you nampak kan ada hole tu kan, ada lubang kat situ. Kita akan wind. Kita akan buat kabel tu, kita akan wind, pusing dekat dia punya tu. Bagi ada looping so that current boleh flow. Current flow series kan. Dia akan flow pusing dekat dia punya winding tu pergi kepada kita punya controller. Kalau voltage kan you buat measurement kan parallel. So dia punya lain lah sikit dia punya bentuk dia. Kalau untuk voltage sensor, dia tak ada lubang kat tengah tu. Dia empat segi je. Okay? Right. So these are the list of application for the power electronics. So basically dia type into various application from low power to high power punya application. Okay. From you punya household punya application, kita ada lighting, you punya aircon, you punya laptop, you punya handphone, semua ada elemen power electronics inside there, you punya printer and so on. And then untuk yang high power kita ada on the EV, and then we have the energy storage. Okay, energy storage ni untuk kita punya backup system And then we have the power conditioning for alternative power sources, which is when we will use solar panels, wind turbine and all that, we need to have this power electronics converter. Right. So ini the illustration of the application. So kalau boleh tengok daripada community, ini the range of power electronics that we use for community, which is household punya appliances. Okay, regional, and also national and also international. Okay, and then this is the importance of power electronics. Okay, dia punya importance which is kepentingan dia. Okay, why is that we need to use this power electronics converter? Because of the advanced kita punya availability of high power semiconductor devices. Okay, dulu, waktu awal-awal dulu, kita punya switch dia come from diode. Lepas tu you ada transistor and all that kan. Lepas tu kita, as we advance from that BJT transistor, kita ada MOSFET, IGBT and even smaller guna gallium nitride punya switch and smaller switches. So in order to control these switches, kita memerlukan power electronics punya converter. Okay? Power electronics converter sahaja boleh control switch. Yang lain tak boleh control switch. Okay, and then bila kita ada renewable energy generation sources, when we have the solar panel, wind turbine, biomass, fuel cell and all that, we need to use these power electronics converter sebab power electronics converter yang boleh buat conversion. Dia nak convert daripada one source to another, one form to another, daripada DC to AC, AC to DC ke ataupun DC to DC. Right. Okay. Right. So this is one of the example. Bila kita ada kita masukkan elemen power electronics control and without power electronics control. Okay, yang blue line kat sini, yang green car ni, okay, yang ni bila kita masukkan power electronics control, which is we have the inverter control. So bila we start the engine, and then when we try to accelerate the car, okay, and this is how by using inverter control, this is how dia punya kita punya room temperature will be, dia akan maintain at certain level. Kita tak tiba-tiba heat up to cool down ke apa ke. Kalau without yang old car, yang very old car, okay, yang without the power electronics punya control, okay, kalau during the start up dia panas sikit, so engine tengah panas kan, so aircon pun tak berjalan sangat, so panas lagi. And then bila you ram, you accelerate, dia akan overcool dia, and then bila you maintain pula, dia akan turun balik, temperature dia varying. Okay, so yang ni yang kita lama. Alright. Okay, and then we go for the converter punya classification. Okay, we have source, of course, our input. We have the converter will be the intermediate between the source and also your load. Okay, your load
Betul,
you
tak
will
masuk
have
sana.
whether it's AC load or DC load, so it depends. Okay. Okay, so for the power electronic circuit which is ini, kita punya converter ni adalah dia punya objective dia is to match the voltage and current requirement of the loads to those of the source. So which is whatever that the rated voltage and current that being needed in your load, kita akan try to match, kita akan suit lah. Maksudnya kalau you punya load memerlukan 100 volt, so you punya converter akan try to achieve that 100 volt so that you be able to supply you punya power from your source to your load. Or else kalau dia tak match, dia tak boleh supply. Source tak boleh pass through your punya load dia. Okay, ini I think the classification tadi yang saya ada mention few times ya. Okay, kita basically untuk power electronics converter kita ada 4 jenis, 4 classification depending on the punya type of the punya form of input and output. Okay, kalau untuk rectifier, this is from AC signal to DC signal. Okay, for rectifier we have half wave rectifier and full wave rectifier. Untuk half wave rectifier ni, you can either have half wave diode rectifier, which is you are going to use diode as the switches, and you can also have half wave thyristor as the switches, which is thyristor is you can have semi control or fully controlled. Diode is uncontrolled rectifier. So untuk rectifier you can have either uncontrolled, which is using diode. You can have semi control and fully control. So semi control kita akan guna thyristor, and fully control kita akan guna semi control guna transistor, fully control guna BJT, which is you punya ataupun IGBT Right, and then same goes to full wave rectifier. Okay, previously, okay, untuk half wave rectifier kita akan pakai 2 saja switch dalam you punya rectifier. Untuk full wave rectifier kita akan pakai 4 switch. Itu dia punya beza antara half wave dan juga full wave, bilangan switch. Okay, and then on the DC to DC converter, ini kita panggil sebagai regulator, which is it will depends on load. Contoh kalau katalah you have buck converter is a step down converter, which is kalau step down you punya input will be higher than your input. Kita nak turunkan kita punya voltage, kita akan guna buck converter. Okay, and then we also have boost converter, which is you punya output will be higher than you punya input, so dia akan boost up. Okay, you punya output voltage. Okay, for buck boost converter dia ada dua-dua. You can either step up ataupun step down. Okay, for buck boost, you can either step up the output voltage ataupun you can step down the output voltage. It will depends on the dia punya control element, what we call as duty ratio ataupun duty cycle. You will look into this once you cover for this DC to DC chapter. Okay, and then we have the third converter classification, which is DC to AC, which is an inverter. Okay, so the input adalah DC, the output will be AC. Okay, so normally inverter ni kita akan connect to kita punya grid lah, sebab grid kita memerlukan AC. Okay, so untuk inverter kita ada half bridge inverter. So half bridge dia guna 2 saja switch. And then kita ada full bridge inverter. Full bridge pakai 4 switch. Kita ada 3 phase inverter pakai 6 switch. Multi level inverter bawah ni, it depends on how many level that you want. Let's say ada 11 level, each level 2 switch. So 2 darab dengan 11 level, 22 switch kita akan pakai. Itu multi level inverter. So it depends on how many level of the inverter that you want. Okay, so dia punya advantage of multi-level inverter ni, basically dia punya output dia, you akan dapat lagi refine lah sebab dia banyak level kan. So dia very refine. Dia punya sine wave itu sangat-sangat refine. Kita akan digitizekan dia punya sine wave. Tak nampak macam sine wave betul. Dia digital kan. Dia bentuk digital tapi end up dia akan nampak macam sine wave lah. Okay, and then the last one kita pakai, kita ada AC to AC converter, which is yang ni kita pakai sebagai cyclo converter. Okay, so far kita tak cover AC to AC converter sebabnya dia punya teknologi dah obsolete. Dia tak ada advancement on the AC to AC converter. That's why kita sebelum ni dia punya senior dah belajar on AC. Kita keluarkan this chapter sebab dia dah teknologi dah obsolete, dah tak ada tak ada any research or ataupun any teknologi that being done with regards to AC converter. Okay, dia ada lagi lah, still ada sebab dia yang masih ada tu yang maintain lah. Tapi yang baru punya teknologi dah tak ada dah. Okay. Okay, power electronics juga kita guna dalam multi-stage conversion. Okay, multi-stage conversion maksudnya kita akan guna 2 atau 3 converter untuk buat conversion ni. Contoh, okay, daripada source, okay, let's say we have AC source. Okay, kita punya load adalah AC, misal load. Okay, kita nak AC, our source is AC, load kita pun AC juga. Kita akan guna 2 jenis converter, which is kita akan convert from AC to DC dulu. This one is guna rectifier, okay, and then DC to AC. This one is using inverter. Okay, so kenapa kita pakai 2 stage of converter is that kita nak maintaining a stable punya output, which is bila kita buat conversion antara one level to another level, kita nak make sure kita punya smooth dia punya conversion dia tak ada transient ke overshoot ke over voltage ke. That's why kita akan guna multiple punya conversion lah. Right. Itu je. So basically this is the conclusion for this introduction to power electronics. Okay, dia punya definition dia, what is power electronic circuit is a converter that convert from that convert electrical power from one form to another, whether it's AC or DC. Okay, dia punya objective of this power electronic circuit is to match sure that this converter able to match the requirement of the voltage and current that required by the load. Okay, we have 4 type of power electronics converter. Okay, we are going to cover 3 saja, which is DC to DC ini, AC to DC and AC to AC. Right. Okay, and then the importance of power electronics. So basically kita nak suit the requirement of advancement in high power semiconductor devices. We want to improve the system performance by improving the efficiency, easy to control and compact in size. Okay, ini dia punya kepentingan menggunakan power electronics. And then these power electronics also can be used as an interface between the source and also with the load for renewable energy generation system. And lastly, okay, kita guna power electronics as the power quality mitigation. So power quality mitigation, which is power quality correction. Contoh STATCOM, DVR and UPS. UPS is uninterruptible power supply. DVR, dynamic voltage restorer. STATCOM, compensator, something lah. So basically, contohnya for STATCOM adalah the element of rectifier kita combine dengan DC to DC converter in order to mitigate. Contohnya power quality mitigation ni, I'm not aware whether you pernah belajar. Kita ada few power quality punya problems. Contohnya kita ada voltage sag. Voltage sag maksudnya daripada kita ada penurunan from nominal voltage, tiba-tiba dia menurun. Okay, so kita panggil voltage sag, and then kita ada voltage swell bengkak kan. So maksudnya daripada nominal voltage tiba-tiba dia besar. So this kind of problem kita nak make sure kita boleh maintain a stable AC. So this one, when this problem happen, kita akan guna this power quality mitigation, contohnya STATCOM, untuk cater for this voltage dip and voltage swell. Okay, and UPS bila kita short of main supply So macam contohnya bila blackout, kita akan pakai UPS lah as punya backup. So inside UPS kita ada converter, kita ada energy storage which is capacitor bank. So ini adalah this is how power electronics converter being used in few of these application. Alright. Okay. Yang ni you dah tengok kan? Okay, I think that is all for today's lecture. Any question? Okay, make sure yang list yang saya bagi itu daripada Amis, yang registered student, the current registered student. So please check, make sure your name are there. Kalau tak berada dekat situ, bilang whatever necessary action. Alright. Okay, tak ada soalan Okay, so tak ada soalan. For this week tak ada lab, kita akan buat lab next week